Geometers and general seekers of truth. We are going to solve a problem that's very similar to the previous problem in this series of videos. And the reason we're solving this problem that has no numbers at all is to illustrate and to understand the power of solving a problem with a variable. We don't merely just want to replicate the same question over and over and over again. We want to use similarities in that question so that we can extract some sort of formula or a general rule, or in this case, a theorem. Okay? And the way that I'm going to approach this is not tell you what the theorem says. We're just going to solve the problem, listing out our steps a little bit at a time, and then we'll know what the theorem says at the end of this. So here, let the measure of arc EC be x degrees. So this arc here is x degrees. And the measure of arc GF be y degrees. Find an expression in terms of x and y for the measure of angle D. So we want to know what's the measure of angle D in terms of x and y. And once we find that expression, that will hopefully help us figure out what theorem that this problem is referring to or setting us up for. So we're going to do the same thing that we did in the previous video, except we're just going to use variables instead of numbers. So the first thing I'm going to do is try to create inscribed angles. So by drawing this line from C to F, and I'll list out my steps here. Construct CF. And from this, we know that the measure of angle CFE has to be 1/2 of arc CE. So this angle here is 1/2 x, or x over 2. And that's from the inscribed angle theorem. So the measure of angle CFE must be exactly equal to 1/2 the measure of arc EC, or 1/2 x. This is the inscribed angles theorem. And similarly, we can see that this arc right here, arc GF, is intercepted by this angle here. So we know that angle C is 1/2 of y, really for the same reason. So the measure of angle C is equal to 1/2 of y. Same reason as what we had above. And now, if we take just kind of extract the picture of the triangle here, that will help us figure out, and I'm going to draw a mini version of the triangle. So let's see. So I know that this angle in here, this is angle C, this is point D, and this is F. So this is 1/2 y. I should write it right here as well, or y over 2. This is angle D, and this is 1/2 x, or x over 2. And from the exterior angles theorem, we can say that the measure of angle C plus the measure of angle D must be equal to the measure of angle CFE. And this is the exterior angle theorem. And so in my last step, step 5, ooh, that's a terrible 5. Step 5, I'm going to rearrange this a little bit because we want to figure out what's the measure of angle D. So the measure of angle D is equal to the measure of angle CFE minus the measure of angle C. And then we can make our substitution here. CFE is 1/2 x minus angle C is 1/2 y. And so we've completed our problem here. we've answered everything in terms of x and y, and we know for a fact, and we can actually simplify this a little bit. We can say that this is x minus y over 2. So, that about captures it for this problem. And we know that because we solve this with variables, it's true for all cases. As long as this setup is true, that we have an angle outside here and two secants that's making up that angle, then the two arcs that it intercepts here must in fact be related to the angle in the following way. The big arc minus the little arc over 2 will give you the angle. Okay, so this is a theorem. We can give this some sort of name later on, but it's important to know that this is a theorem, that it's true for in the general case, and we have a neat little formula for finding the angle that's outside of this circle formed by two secants. I'm gonna leave it up to you to show that this is true for some other cases, like what if this is a tangent line instead of a secant line, but we can do that in another problem. Hopefully you see how between this video and the previous one, you see how we're able to go from a specific problem to a general problem and complete a proof. Thank you for watching. Keep working, keep struggling. Struggles in mathematics are how you really truly learn. As always, ask for help if you need it, and have a wonderful day.